This is a revision video for GCSE Geography, Water on the Land, and it's for the AQA A specification. But I suppose it can apply for any exam board really, but this is mainly for the AQA specification. Now, I'm gonna start off with keywords. These aren't all the keywords, but these are the keywords that I thought were the most important and come up in several topics. But there are other keywords which I include throughout the rest of the video. So firstly, there's the channel, which is the part of the river valley occupied by the water. There's vertical erosion, which is downwards erosion, and I'll go into more depth throughout the video about vertical erosion, and it's mainly dominant at the source. Then there's lateral erosion, which is sideways erosion, and again I'll go into more depth throughout the video, but it's mainly dominant in a river channel on the outside bend of a meander. The load is the material of any size carried by the river. The discharge is the volume of water passing through a point of the river at any point in time. Sorry, I missed a word there. Flashy is a hydrograph which responds quickly to a period of rain, so its characteristics show a high peak and short lag time. Now, if you don't know what a hydrograph is, I'll go through this at some point in the video. Relief is the height and slope of the land. Impermeable rock is rock which water cannot pass through. Porous is rock which water can pass through and soaks in through spaces in the rock. And pervious is rock which allows water to pass through via vertical joints and horizontal bedding planes. Now, firstly, it's the long and cross profile of a river. So this is the long profile of the river, which shows how the steepness of a river changes, a river valley changes, throughout the course. And the cross profile is these little thingies here. Don't really know what they're called. I suppose little diagrams to show the width and the depth of, Anyway, so the upper course, which is at the source, has a shallow and narrow channel. It has vertical erosion is dominant here. Processes of erosion that are dominant include hydraulic action, attrition, and abrasion. There is some traction, but there's a high rate of siltation. There is a large load of material deposited. Could have put that together actually, but this is the cross profile of the river at the source. So as you can see, it's quite I was meant to be shallow, but it's quite narrow, as you can see. The middle course of the river has a wider and deeper channel. There's some vertical erosion, but lateral erosion is more dominant. There's less hydraulic action. Suspension is the main process of transportation, but there is also some siltation and traction. There is less load deposited, less load being carried, and there's more deposition. So this is the cross profile for the middle course. As you can see, it's wider and deeper. Now, finally, the lower course of the river, which is the mouth. This is where the river meets the sea. There is a very wide and flat valley, as you can see here. It's wide and deep as well. Erosion is not as important, but there is some lateral erosion. Suspension is dominant, and there is a lot of deposition of fine material. Now, types of erosion, there is vertical erosion and lateral erosion. So vertical erosion deepens the river valley and channel, which makes it V-shaped. It is also dominant in the upper course of the river, whereas lateral erosion widens the river channel and river valley and channel, which is dominant in the middle and lower course. So vertical, if you think about it, goes downwards, so it deepens the river, whereas lateral goes sideways, so it's making it wider. Now, there are 4 processes of erosion in the river, which is the same processes as in the coastal zone, but it's slightly different. So hydraulic action is the force of the river water which breaks rock particles away from the river channel. Abrasion, which is eroded rocks which are picked up by the river and rub against the channel, which causes it to erode away. Attrition is eroded rocks which are picked up by the river and smash into each other. As a result, they break into smaller fragments and their edges get rounded off as they hit into each other. And solution, which is rock types such as chalk and limestone, so soft rock, which dissolve in the river water. Now, transportation in the river, there are 4 processes of transportation. The first one is traction, which are boulders pushed along the riverbeds due to the force of the water. Siltation, which are pebbles which bounce on and off the riverbed. Suspension, which are small particles such as silt, which are carried by the river water. And solution, which are soluble materials which dissolve in the water and are carried along. Now, there's just a diagram here to show you. If you're a visual learner, I think this will help you to remember the processes better. And deposition is the process of the river dropping material that it is transporting, and it happens when a river slows down or loses velocity, in other words. And why does it happen? Well, there are 4 reasons for this. First one, the volume of water in the river decreases. The amount of eroded material in the river increases. The river water is shallower, so at the source of the river, for example, or the inside of meander bend, or when the river reaches the mouth. Now, river landforms. Firstly, meanders, which are a bend in the river, which is formed by when the current is faster on the outside of the bend, as the river channel is deeper, so there's less friction to slow the water down. As a result, more erosion occurs on the outside of the bend, which forms river cliffs. On the inside of the bend, the current is slower as the river channel is more shallow, so there's more friction to slow the water down. Therefore, eroded material is deposited on the inside of the bend, which forms slip-off slopes. Now, an oxbow lake, which is a semicircular area which used to be a meander. So they're formed from meanders, and erosion causes the outside bends to get closer until there's only a small bit of land left between the bends, which is called the neck. Then, the river breaks through the land during a flood, and the river flows along the shortest course of the river. Deposition then cuts off the meander and forms an oxbow lake. Waterfalls are a vertical drop of the river along the course. They form where a river flows over an area of hard rock, which is followed by an area of soft rock. A step is created in the river as the softer rock becomes more eroded than the harder rock. As water goes over the step, it erodes more of the soft rock. Then a steep drop is created, which is the waterfall. Gorges are formed from waterfalls, and they are narrow, steep-sided valleys. Hard rock is eventually undercut from the waterfall by erosion and then collapses due to the fact that it is unsupported. The collapsed rock swirl around the foot of the waterfall, where they erode softer rock by abrasion, which creates a deep plunge pool. More undercutting causes more collapses. The waterfall moves back up the channel, retreats, which leaves a steep gorge. A floodplain is a flat area on either side of the river which is rarely flooded in the lower course. It is a wide valley floor on either side of the river which occasionally gets flooded. I've already said that. But water slows down and deposits eroded material which it transports when a river floods onto a floodplain. This builds up the floodplain, making it higher. The floodplain becomes wider and meanders migrate across the floodplain. Deposition on slip-off slopes of meanders also build up floodplains. Levees are raised banks of deposited material along the river course. Eroded material is deposited on a river during a flood. The heaviest material is deposited closest to the river channel, as it is dropped first when the river slows down. Over time, deposited material builds up, which are levees along the course of the river. So, coming back to hydrographs, it is a line graph drawn to show the discharge in a river in the aftermath of a period of rain. So as you can see, the y-axis is usually precipitation in millimeters, and the x-axis is the time. So this is midday, this is midnight of day 1, midday, midnight of day 2. So the rising line here is called the rising limb, and the falling line is called the falling limb. Now this dotted line across here is a normal base flow, and the top of the line graph is the peak discharge. And this bit here shows the peak rainfall and how much has fallen in millimeters and what time of day. Now the relationship between peak rainfall and peak discharge is called the lag time. Got that? If trees are removed, water reaches the surface faster, and trees do not extract water from the ground. Urbanization means that buildings and grounds built out of impermeable materials such as concrete, which increases the rate of surface runoff which floods into the river, because, well, as rain falls onto an impermeable material, it's obviously not going to be able to soak in. Now, rock type, a physical factor, is when water infiltrates through pores in permeable rock and flows along cracks in pervious rocks, which means that there's less surface runoff, which increases the lag time and decreases discharge. Water cannot infiltrate into impermeable rock, so volume of water in the river increases. So again, increased surface runoff means there is a decreased lag time and an increased discharge. Relief, another physical factor, is, well, basically it's a lot of surface runoff occurs on steep slopes, as obviously it's steep. If you roll down a hill, you're obviously going to go faster than if you roll on flat ground. So lag time is decreased, so discharge is increased. Now, temperature, another physical factor. Hot, dry conditions as well as cold, freezing conditions result in hard ground, typo there, hard ground, which increases surface runoff. Also, greater water loss via evaporation and transpiration when temperatures are high. So there is a greater water loss. And the amount and type of rainfall. There's lots of rain and short, heavy periods of rain increases the rate of surface runoff. High amounts of rain saturate the soil and underlying rock, whereas drizzles allow water to have time to infiltrate the soil and rock, which frees space for more rain. Now, flooding. There are physical and human factors to flooding. Prolonged rain, a physical factor, is when soil becomes saturated after a long period of heavy rainfall. After this, further rainfall cannot infiltrate, so surface runoff increases. Discharge increases. Another factor is heavy rainfall. A lot of rainfall increases the rate of surface runoff, which quickly increases discharge, so it causes a flood. Snow melt is when snow or ice melts. A lot of water goes into the river in a short space of time, which increases discharge quickly. Now, this one wouldn't apply to many places. I mean, in England, for example, you don't get huge amounts of snow, quite rare, but yeah. Relief is, again, a river with a steep-sided valley, which means that water can reach the river channel quicker, as water flows on quicker on steeper slopes, which increases discharge. Now, human factors. Deforestation. Trees intercept rainwater on their leaves, which evaporates. They also take up water from the ground and store it. This means that cutting down trees will increase the volume of water, which then reaches the river channel and increases discharge, becoming likely to flood the river. Buildings construction, which are often made from impermeable materials such as concrete and are surrounded by roads made from tarmac, which is also impermeable. Impermeable surfaces do not have pores, so they cannot absorb rainwater. Rainwater. As a result, rate of surface runoff increases and causes more flooding in the river, so discharge increases. A case study for flooding is Cockermouth in the UK, 2009, and you may not have done this case study in school, but it's still applicable. You can still learn this one, or you can just forward the video a bit. But anyway, causes of the Cockermouth flooding 2009. On the 19th of November 2009, there were the highest rainfall level recorded within 24 hours on the Hill of Lake District. Saturated ground which saturated the ground and fell rapidly down hillsides into rivers. Cockermouth lies on the confluence of two rivers, the River Derwent and the River Cocker. There was a large volume of water bursting their channels, so rivers burst their banks, causing widespread flooding. The effects of the flooding: 2.5 meters of water cascaded down main roads, destroying shops and homes, which it is a social impact as people lose their homes, and an economic as well as people lose business. Shops were destroyed by 1 meter of mud and silt, so again, another economic impact. 1,300 people were directly affected by the flood, which is a social impact. All of Cumbria's 1,800 bridges had to be inspected for safety. Several bridges were completely destroyed. Insurance companies expected the cost of the damage to be at least £100 million. Farmers suffered from the inundation of land and livestock were killed. Also, pastures became useless as they were too saturated or became coated with rocks. And the responses to the flooding: 200 people were airlifted from homes by the RAF helicopters and evacuated to temporary shelters. People lived in temporary accommodation for months, maybe even a year or two, as their homes were filled in muddy water. The main road bridge of the River Derwent was closed for 2 months for safety checks and repairs, and the streets were filled with skips for damaged belongings. Now, another case study for flooding is Bangladesh 2004, and Bangladesh is an LEDC, whereas Cockermouth in the UK was an MEDC. I forgot to mention that. So there are 4 main causes of the Bangladesh flooding. Firstly, deforestation, as people chop down trees in the forest to cook with. Flat, low-lying relief on the delta of the Ganges River. Tropical cyclones bring less pressure and raise sea level. And 70% of Bangladesh is less than a meter above sea level. So there were 5 main effects of the flood. Over half of the country was underwater, an environmental impact. There were 600 deaths, 30 million people homeless out of the 140 million population, 100,000 people with diarrhea, 40% of Dhaka was underwater, and 60% of Bangladesh had submerged by July 2004. The airport flooded, so there was no tourism, which impacts the economy as tourism is one of Bangladesh's, main income, if you know what I mean. And food supplies such as rice and vegetables were lost, and cash crops such as jute and sugar were destroyed. Responses to the flood: food supplies, medicines, clothing and blankets were distributed, a short-term response. Local communities began to rebuild homes, long-term response. Water Aid sought to supply water purification tablets and posters highlighting hygiene risks in floodwater. And the provision of food shelters are built along rivers, which is better than on embankments, which are areas of raised land where people can move to temporarily with cattle and access to items such as dried food. And now, hard and soft engineering of rivers. Hard engineering, an example is dams, which are huge walls built around a reservoir, which is an artificial lake. Reservoirs store water during periods of prolonged rain, which reduces the risk of flooding. And also, the water can be used to drink and generates hydroelectric power, which is an advantage, obviously. However, a disadvantage is that they are expensive to build, and the eroded material is deposited in the reservoir and not in the river's natural course, so farmland is less fertile. Another example of hard engineering is channel straightening. Water moves out of the area quicker, which reduces the risk of flooding as it doesn't travel as far. So this is obviously an advantage. However, A disadvantage is that flooding can occur downstream of the strait and channel as water is carried there faster, and more erosion occurs downstream as water flows faster. An example of soft engineering is basically to do nothing. So this is positive for the economy as no money is spent on engineering, and people believe that others should accept the risk of living in an area that is likely to flood. The benefit is that when the river floods, eroded material is deposited on the floodplain, which makes farmland more fertile, which is beneficial for farmers who can make a better income by selling their crops. However, disadvantage, which is quite obvious, is that it can cause a lot of damage to people's homes, belongings, shops, all of that. And the second example of soft engineering are flood warnings, and the Environment Agency warn people about floods through radio and newspapers. The benefit of this is that it gives people time to move their possessions upstairs, if they have an upstairs. It gives them time to evacuate and put sandbags in place. On the other hand, the disadvantage is that people may not have access to hearing or reading about the warnings, and warnings don't reduce the impact of floods. So either way, it's still going to. And this is a diagram showing the UK's regional population density. So as you can see here, London is quite highly populated, whereas the rest of England is, more or less, and Northern Ireland, so average. And in Scotland it's quite low. So there is a lot of rainfall in the north and the west of the UK, which means that there is a good supply of water. However, in the southeast and the Midlands of England, there is a high demand for water as the population density is much higher. The southeast and the Midlands are areas of deficits as there is a greater demand for water than supply of water. However, the north and west of England are areas of surplus as there is a greater supply than demand of water. Now, demand for water in the UK is increasing as volume of water used by people over the past 25 years has increased by 50%. Also, the UK's population is predicted to increase by 10 million over the next 20 years. Managing water supply and reducing demands. Managing the water supply. An example of this would be transferring water from areas of surplus to areas of deficit. For example, the Kielder Dam transfers water from the north of England to north of the UK, to Newcastle, which is a very industrial area where factories require water. Another example is to build more reservoirs to store more water, but this can cause problems as some people may have to relocate. And also, fixing leaky pipes means that less water is lost during transfer. For example, in London, millions of litres of water are lost a day due to leaky pipes. Now, reducing demands. People can reduce the amount of water they use, such as having less baths and more showers, or only running washing machines when they're completely full. Also, when you're brushing your teeth, loads of people tend to leave the tap running, but you can just turn it off and then turn the sink back on when you actually need it. Water companies can install water meters instead, which is used to charge the exact volume of water they use, which means that people will be much careful of how much water they use, as they do not want to pay a lot for it. Now, managing the UK's water, and again, you may not have used this case study, but still good to know. So this is the Kielder Dam case study. Positive impacts of the Kielder Dam is that hydroelectric power stations, which uses Kielder's water to generate 6 megawatts of power, which obviously is economic as you save money on energy, and environmental as there's less CO2 emissions. A visitor's case study shows that £6 million is raised through tourism to Kielder Dam each year, which is an economic factor. Obviously, there's more income being made. Kielder Dam includes 8 sites of special scientific interest, the SSSI, which covers 7,800 hectares. I think that's hectares. It was written in my book, and contains many unique plants and animals such as the red squirrel. Kielder is one of the last places for red squirrels in the UK, which is an environmental impact. A social and economic impact is that there are 200 employees at Kielder Forest. Also, huge volumes of timber are produced at Kielder Water each year, and there are 150 million trees which are replanted once felled. It also acts as a flood prevention measure, and it is an 11-kilometer long lake which stores up to 200 million litres of water, which helps during water shortage. Now, negative impacts is when the dam was completed, it flooded an area of scenic natural beauty. Clean water results in potential for erosion downstream of the dam, which is known as clear water erosion, an environmental impact. 2,700 acres of farmland and habitat was lost as a result of the scheme, another environmental impact, and 58 families were displaced from their homes by the dam, and their houses disappeared below the lake which is formed, which is a social impact. And Kielder Forest has been criticised for being too much of a monoculture, which is basically only one type of tree grown, mainly the sicked spruce, which is again an environmental impact. So to summarise water on the land, this is just a quick quiz. So if you just want to maybe pause the video and answer the questions, but I'll just read the questions to you first. What is lateral erosion? What is a meander? Give an example of hard engineering. What is an advantage of flood warnings? And give a positive impact of Kielder Dam. And the answers: lateral erosion is sideways erosion which widens the river valley and is dominant at the lower and middle course of the river. A meander is a bend in the river, usually in the middle course. An example of hard engineering are dams and reservoirs. Flood warnings allow people to evacuate, take possessions upstairs and put sandbags in the house, and Kielder Dam generates 6 megawatts of hydroelectric power. So thank you so much for watching this video. It's my first video, and obviously got quite a few typos, which I just typed really quickly, and I was kind of in a rush to make this video. So that was my first video. Hope that was alright, and I hope this video has helped you with your revision much more, and hopefully understand the topic much better, and that you'll get a fabulous grade in the exam. So thank you for watching, and good luck.